Welcome back to the Deep Dive. Today, we're jumping into something really shaping the future right now. SimAI. That's simulation plus artificial intelligence.
Exactly. And we know your time is valuable, you want knowledge fast, but also, the real substance. So that's our mission here.
Yeah, we want to get past the buzzwords.
Right. We're going to unpack what SimAI actually is, show you where it's already working, making a difference in the real world.
And look at the evidence, the data behind it.
Absolutely. And also step back and consider the bigger picture, the trade-offs, without getting into panic mode.
Okay, so when people think of automation, often it's still that image, right? The robot arm on the assembly line doing the same thing over and over.
That's the old picture. SimAI is, well, it's the next level. It's not just doing, it's predicting, it's adapting, it's improvising almost, faster than we've ever seen before.
So our source material frames this as a convergence.
That's a good way to put it. A convergence of physical AI embedded in the machine itself and these incredibly detailed simulations, high-fidelity simulations.
And it's moving fast, not just theory anymore.
No, definitely not. It's moving from, let's say, science fiction straight to the factory floor.
Yeah.
And it's already giving efficiency a serious boost. That acceleration, that's the hook.
Okay, let's get into that convergence then. A clear definition. SimAI, combining super realistic digital models with AI. What's the core mechanism that makes it different?
The secret sauce really is rehearsal.
Mm.
The AI builds these virtual playgrounds, these digital twins.
Okay.
And in these twins, the machines can run through scenarios thousands, maybe millions of times, testing things out in the virtual world before trying anything in the real one.
So it's like a stress test on steroids. The machine learns what works, what doesn't, predicts failures, all before lifting a finger, essentially.
Exactly. It runs through all the what ifs. What if this part is slightly off? What if the temperature changes? It rehearses for chaos, but safely, virtually.
And that builds up this deep understanding.
Precisely. An internalized model of physics, of complexity, which loops back to that physical AI idea. It's not just a done arm getting instructions.
Right. Is the intelligence in the machine itself, or is it still mostly a central brain directing traffic? I think that's key for people to understand.
That's a really good question. Often it's a bit of both, but SimAI really emphasizes that powerful central intelligence doing the heavy lifting before the action.
Yeah, okay.
So unlike basic automation following a script, this AI is like, I don't know, a grandmaster chess player, thinking multiple moves ahead.
Calculating all the outcomes.
Exactly. The physical machine then gets this highly optimized, pre-tested plan. It can then make decisions in milliseconds based on all that groundwork.
And we're seeing companies really scale this. You mentioned Sima.ai.
Yes, companies like SimAI are pushing this hard into robotics, automotive, even healthcare. It's becoming foundational.
So the bottom line, what are the actual efficiency gains we're talking about with this rehearsal method?
The numbers are frankly pretty staggering. We're seeing efficiency gains in complex industrial processes jump by 30 to 50% already.
30 to 50%. That's huge. That's not just tweaking, that's transforming operations.
It really is. It fundamentally changes the cost structure, the time to market, everything.
Okay, 30, 50% is a big range. Where do you see the higher end of that? Is it manufacturing or maybe logistics with all its variables?
Yeah, you often hit that higher end in really complex, dynamic environments. Think logistics, advanced manufacturing, places where you have tons of variables, material tolerances, heat, supply chain hiccups, you name it.
Right.
The AI is juggling all those parameters at once, something humans or even simpler automation just can't really do effectively.
Those numbers are impressive, but, how solid is the evidence? How are these gains being measured on the ground?
Well, the power of these AI simulation tools is that they're not just theoretical. They blend analytical models, the physics, the math, with real-time data streaming back from the physical world.
Ah, so there's a feedback loop.
Exactly. It's constantly learning and refining based on what's actually happening.
And that leads to predictive precision.
Bingo. Logistics is a prime example. In massive warehouses, these tools are predicting workflow with up to 95% accuracy.
95%.
Think about Amazon gearing up for Black Friday. Their robots aren't just guessing based on last year. They're running simulations, avoiding bottlenecks, what one source called Black Friday zombie chaos, which I thought was funny.
Yeah, but 95%, that still leaves 5% error, which in a huge supply chain could be disastrous, right? How does SimAI handle that gap?
That's a really critical point. It's not about eliminating all error. Nothing can do that. It's about having the intelligence to mitigate that 5%.
Okay, how?
Because the AI has already simulated thousands of potential failures, it knows the best, fastest response when something does go wrong. It can reroute things, shift resources in milliseconds. It turns a potential catastrophe into maybe just a small delay.
It changes the whole risk equation then.
Completely.
And it's not just about making current processes smoother, it's speeding up innovation too, right? Like in the design phase.
Absolutely. The speed gains in design are remarkable. Research from folks like ANSYS shows that for really complex simulations designing, say, a new wind turbine blade or aerospace parts, AI can accelerate the process by 10 times.
10 times faster. So weeks of number crunching become hours.
Pretty much. Weeks down to hours.
Yeah.
And even for general design workflows, we're seeing things speed up maybe 5 times overall.
Wow.
It frees up engineers. They can focus on the creative problems, the bigger picture, while the AI handles the brute force simulation work.
Okay, let's make this even more concrete. Pivot to some real-world applications. Where does the semi-magic actually happen? Let's start with manufacturing.
Yeah, manufacturing and robotics are sort of ground zero. You've got systems using tech like NVIDIA's AI, allowing robots not just to do, but to see and make decisions right there on the spot, integrating sensors, deep learning. It's all happening in milliseconds.
And the level of detail in the simulation is mind-boggling. Like that example of a robot putting in a screw.
Right. It might simulate, 1,000 tiny variations, different angles, torque, material inconsistencies,
Correct.
all before it makes the actual move.
That's surgical precision, taking human error almost out of the equation for that specific task.
Pretty much. And that same idea, that precision, carries over into healthcare too.
How does SimAI work in medicine?
Well, think personalized medicine. You can create a digital twin of a patient. Then the SimAI can simulate how different treatments might work for that specific person.
Like predicting drug interactions
Right.
or finding the perfect chemo dose.
Exactly that, based on their unique physiology. And the data suggests this is already cutting medical errors by somewhere around 20 to 30%, moving away from one size fits all.
That's incredibly impactful. Okay, from hospitals to farms, agriculture is using this too.
Oh, yeah. A 2025 study we looked at highlights machine learning and semi-optimizing farm machinery. Not just self-driving tractors, but way beyond that.
How so?
The simulations model everything. Soil conditions, water levels, weather patterns, even how the equipment itself wears down.
It's like giving your tractor a PhD in agronomy and engineering.
Huh. That's a pretty good analogy, yeah.
Yeah.
And the result. The study showed about a 15% increase in crop yields.
15% is significant.
And crucially, it did this while minimizing environmental impact. Less fertilizer waste, more efficient water use, smarter farming.
Okay, so the benefits are clear. Massive efficiency, innovation catalyst. But let's shift gears. We have to talk about the flip side. The societal impact, the workforce implications.
Yeah, this is the unavoidable and frankly really important part of the conversation, the impact on jobs.
Right. What's the consensus there? Or is there one?
Well, the findings are kind of split, honestly. You've got optimistic views, like from the World Economic Forum. They suggest AI will mostly augment jobs, maybe by 40%, by taking over the repetitive, data-heavy tasks, freeing up humans for more creative, strategic, more human roles.
That's the positive spin. SimAI handles the complex stuff, humans direct. But there are serious warnings about displacement too, aren't there?
Oh, absolutely. Other research uses starker terms like revolution and disoccupation. The fear is if this tech advances super fast and we don't retrain people, jobs based on routine tasks, physical or analytical, could disappear very quickly.
So retraining becomes critical. Reskilling, upskilling. What's the scale of that challenge?
It's massive. There are ambitious global targets floating around, like getting 50% of the workforce skilled in AI-related competencies by 2030.
50% by 2030. Wow, that's a huge undertaking.
It is. And it's not just about coding. It's about learning how to work with these systems, how to manage them, interpret their output. Humans become the conductors of this automated orchestra, if you like.
That makes sense, but it needs huge effort. Now, another critical human element, bias. What about the data these simulations learn from?
This is a huge red flag. AI learns from data. If that data reflects historical biases, and let's be honest, a lot of historical data does the AI can learn and even amplify those biases in its simulations?
So garbage in, biased garbage out, essentially.
Pretty much. If the AI is trained on a flawed script, it'll perform a flawed play. We see major concerns in medical AI, for example.
How so?
If the patient data used for simulations isn't diverse, doesn't represent everyone, the AI might generate treatment plans that work better for some groups than others. It could actually worsen health inequalities. if we're not careful.
So constant human oversight on the data itself is crucial.
Absolutely critical. Ensuring data is fair, diverse, ethically sourced before the AI starts its rehearsals.
And then there's security, governance. If these things are simulating millions of scenarios, including potentially catastrophic ones, how do we keep that contained?
Yeah, regulation is scrambling to catch up. We need robust legal frameworks. You see organizations like the International Atomic Energy Agency already proposing rules for AI in super high-stakes areas like nuclear power.
Rules of the road for smart machines.
We definitely need them, especially where a simulation meets real-world action with potentially big consequences.
So wrapping this up, this deep dive shows SimAI isn't just an upgrade. It feels more like a renaissance in automation. It learns, adapts. It's incredibly powerful.
It is. The core message, I think, is still optimistic. It's an innovation catalyst. It brings efficiency. It manages complexity-controlled chaos almost.
But only when guided well, right? With ethics, with human curiosity leading the way. We need to be the vigilant directors, as you said.
Exactly. It elevates human capability if we steer it right.
We've hit the efficiency gains, the precision, the need for retraining, the ethical data challenges.
So maybe the final thought to leave you with as you process all this is about access. Equity.
Right. This tech isn't cheap.
Not at all. SimAI needs serious computing power, massive data sets, specialized expertise. Not every company, not every country can afford it right now.
So the challenges.
How do we democratize this? What policies, what open source efforts, what collaborations do we need? How do we make sure SimAI doesn't just create a world where the biggest players get even further ahead, widening that gap?
Preventing a SimAI divide.
Exactly. How do we ensure the benefits are shared more broadly? That's the big question we need to grapple with next. Something for you to think about.